So this is our problem statement. This is what we are solving. Given a nested table that can contain numbers, other tables, and different data types, write a function to extract all the numbers into a single flat list. I don't know. This one is chat GPT generated, so ignore this. I just wanted to show you this. So this is my table, of course. So yes, this is what I wanted to show, right? I wanted to show that inside the table, all we have to print is only numbers, right? No, first of all, what we have to do is extract all the numbers from here, make it into a new table right here, and then print it, right? Also, I wanted to use this function math.max and table.unpack. Right? We can't use this function on this kind of table, this nested table. We can't use this. So we had to make a table that only has numbers. So that we can use this. So right. So let's start. So this is a function, NW list item, and we created a new table here, and new table, and this. So of course we use the if type items equal to number, then table.insert new table item. So if it's a number, right, then insert in this table. If this item is a number, then insert in the new table, right? Then what if it's a table? If right here there's this numbers, there's inside the numbers, there's inside the numbers inside the table. So this table.insert if this item is a table, then what we do is we create for loop, and for I, as you can see, for I value in I pairs item, right, do local sub new NW. This is what recursion is, right? NW list value. So and of course so this value, this creates its own table, right? So here it's a different, and it just stores a different table, right? And we created again this local variable called local.sub, so that we can contain all the values which are which will be we found out during the recursion in, right? So it goes table and tables and tables and tables and tables, and it will all be stored in the sub. So to access this whatever tables are here, we again use for loop. So for loop, I mean the sub, this is, and again we do table to insert new table, we end and then return the new table. So I will I'll compare these to this shared result a kilometer approach, and of course this result and merge approach. I wanted to compare these, right? So first I will tell what this does. So this local result, then again this is the printing. So this new table is created right here, return new table. So now we have to print it. So as you know, we'll use the function new list on this table, right? Item will become my table. So we'll use this here, and of course we can't access the table, we can't access the values of table without a for loop. In Lua, this is I guess Lua's bad thing. We can't access it without for. So if I wanted to print direct my table or result, what will come in the table? Some random values. This random value is where the table is stored. So I don't want it. I want the result that is stored inside the table, right? So for that we have to use for loop, and we do this and print. This is what also I wanted to use this math.max and table.unpack. This table.unpack, what it does, it creates a list, right? And this result, right? So of course it's a table here. It's a table, right? So what the table unpack does is it creates tables. From tables it creates a list, and that list is used by math.max to compare the values. So we use this math.max compares the values from this list that was made by this table.unpack, and of course we print the biggest num right here, This biggest number is a variable to find the biggest number inside of the output, and then we print it. Right? It's the same question, but of course this is the same table, but there it is a different approach. Right? So what are we doing here is, here there was this new table. So what it it creates its own new table every time the recursion goes, it creates its own new table. But here, this result, it ensures that initialize the result. Here you can see we put the result inside the function only, so that only one table is there to so of course I'll start. So locally function item is the same thing, but just here it is so that we can save the same table, and here it is result equal to result, or so this ensures that we initialize the result table only once. So every time the recursion hits, we don't have to create a new table or new stored value, right? This is what recursion does, right? It stores every value inside a new table. We don't want that. We want it to store in the same result, in the same table, right? So this is where it comes, result table. So of course if it's a number, then when a number is found, it is directly inserted this table. And what if it's a table? So if it's a table, right, like this table, so we use, of course we use else if, and to access the values or numbers inside the table, we have to use this for loop. So we use for loop and IPS item do NWS value and result, right? So recursion, so this is what recursion is. And here recursion is called again, but instead returning a new table, right? Like in this case, it used to, this local sub, it used to create new table, right? If it's a number, it will be stored in a different table, and if it's a recursion, this 2 and 3, right, it will be stored in a new table. So this case we had to merge, like here you can see we had to merge this so that one whole table is created. But here we use a common shared table, and all the values are directly stored inside this result, this table. All values are shared inside of this table directly. But here we were putting the values in this sub. If it's a number, then it will be directly stored here, right? But if it's a value, then this sub will be used, and new tables will be created. So right, so that is what it does. Does this? So yeah, that's what it does. And of course, which is better? So here there will be this will create many tables, but this will create but only once, right? It will only just put the values inside or keep updating it. Here we need merging. We need all this table to merge once, right? Here, like here, where return new table, we merge here, and here we merge all the tables here, and this value return, and then it is printed. But here no merging is needed, because all of the values or items or numbers, it's all shared inside the same table. That is this result. This is more its style is functional. Its style is in place. This will be more. This will use more memory than this one. This will comparatively, this will use low memory, but this will be like if you see, this is easier, right? It's just easier. And so this one, what does it returns, then it captures right here, and then it merges, right? It merges here. Here it merges here. But what is this? It just pass. It just update. It finds. It passes. It updates, and then it just return the result in the same table. So yeah, this is what I wanted to do. Thank you.